Hey, Algebra 2. This is Mr. Osborne. As I promised, I'm going to make a help video for those word problems that we worked on Wednesday for the solving a system of equations by graphing. Those word problems that you guys all love so much, right? So I'm going to do a couple examples here to kind of give you guys an idea of how to start these problems and how to work them out. Okay, so I've got an example here on the screen. This is IXL, so it's one of the randomly generated problems. So let's just go ahead and read through it and kind of highlight what the important information, and then go ahead and graph our graphs. So it says Shauna flew home from vacation with a heavy bag. With the first airline she flew, Shauna had to pay $20 to check her bag, plus $6 for every kilogram that her bag was over the weight limit. So let's stop right there. So right now, Shauna is her name. Just to check her bag, it costs $20. Okay, so right off the bat, the flat rate is $20. Then if her bag was over the weight limit, it cost her $6 per kilogram that it was over the weight limit. Okay, so let's say the weight limit's 50 pounds and she went over the weight limit by I don't know, 3 pounds. It would be $20 for that first 50 pounds, and then for the extra 3 pounds that she's over, we do 3 times 6, which is equal to 18. So that would be an additional $18 you have to spend. Pretty expensive, right? Okay, so just so you have an idea what that means. Okay, so that's the first airline. Okay, choose a new color. Okay, now the second airline, the next flight, with another airline that had the same weight limit, Shauna had to pay $7 per kilogram that her bag was over the weight limit, in addition to the checked bag fee of $15. So with this next airline, she pays right away $15, so we can call that a $15 fee, and just to make everything the same, call this a $20 fee for the first airline. And so she paid a $15 fee for the second airline, and then for every kilogram that she's over for this airline, she has to pay $7 per kilogram. Okay. Now the question is, by coincidence, the fees ended up being the same with both airlines. Okay. How far over the weight limit was the bag? So in other words, she ended up spending the same amount of money. So we got to figure out what was the weight of her bag if she ended up spending the same amount of money. Okay, so let's open these notes up a little bit so we can see the screen a little better. Okay, so remember, like I showed you guys in class, we're going to take this information and we're going to make two line equations, or two equations or functions in slope-intercept form. If we remember, we need two pieces of information. We need slope and a y-intercept. With those two pieces of information, we can make a graph. Okay? So for this first one, the phi is going to be the y-intercept, because, like I said in class, it's our starting point. Okay? There's this here. Because it's our starting point. Okay? Now, the $6 per kilogram means that every time that she adds a kilogram to her bag, it increases by $6. And that's our slope, which is also our rate, or rate of change. And then it's the same for this for the other airline. So y-intercept here, it's also our starting point, and slope here. So now we can make an equation. So for the first equation, let's do it in red so we're consistent. Let me move this over a little bit so we have more room to work here. Okay, so for this first equation, let's just write it right here. We know we're going to start with y. The rate is $6 per kilogram, so 6 times x plus 20 is our starting point. Then, choose a little bit thinner. There we go. So now for the second airline, it's going to be y equals $7 per kilogram, so 7x plus 15. There we go. Now we've got two equations that we can go graph them. Alright? So let's add that here. Let's go back to our, let me bring up this other one. Move this over a little bit. So there's our equations. So let's go ahead and graph them. So let's look at the first one here. This one here. Now, go to our graph. We start at 20, so that's our y-intercept. So let's go ahead and graph that. Now, the slope is 6, which is also 6 over 1. So m is 6 over 1. Now here's the difficult thing, because when we look at this graph, it goes up by 20, 5, 30, 35. It goes up by 5s. So I can't just go up 6. That doesn't work. So what I'm going to do is I'm going to multiply this 6 over 1 by 5, because this goes up by 5s. So I'm going to multiply it times 5. And I got to do it to the top and bottom. So now it's 30 over 5. So it's the same slope. It's almost like, you know how we do reducing and we do the reverse? And let's say I give you a fraction like this, I'd say reduce it. And you would tell me, oh, it reduces to 6 over 1. We just did the reverse. Okay. So now we can do, so it's the same slope. We're going to go up 30 from 20, 10, 15, I'm sorry, 10, 20, 30, and we got to go over 5. 1, 2, 3, 4, 5. Boom. There's our first line. Okay, now our second airline. So there's our equation. Starts at 15, and it's 7 over 1. So I'm going to do the same thing to change my slope. Go back to blue. My slope is 7 over 1. So I'm going to multiply it the top and bottom by 5. And I'm multiplying it times 5, guys, because if you go back to our graph, the y-axis goes up by 5s. Okay, so if it went up by 10s, I'd multiply it times 10 and figure out a number that fits on this axis to make it work. Okay, so 35 over 5. So now I'm going to go up 35. So 15 plus 35, that's going to be 50. So it goes all the way to the top and over 5. And there's our intersection point. So the bag ended up weighing 5 pounds over the weight limit. And it ended up costing her the same thing. And like I said before, if you want to double check your work just to make sure that you know you got it right, plug that point back into your equations. Make sure it works. So the point is 5 and 50. So I'm going to plug it back into the first one. Let's get a little red color here. I'm going to plug in 5, my x value, and it should end up being 50. So y is equal to 30 plus 20, and as we can see, it is 50. Okay, so it does work. Alright, so let's plug that in. Drum roll. Yay, it congratulated me. Alright, okay, so let's do one more. Actually, I'm going to do a new video for the next one.